Thank you for watching the Town of Franklin's Stormwater Control Measure Inspection and Maintenance Training video. This training is geared towards residents, businesses, industrial operations, institutions like churches and hospitals, and state or federally owned properties that contain structures designed to manage stormwater. This training video will describe why managing stormwater runoff is important, the ways stormwater runoff is typically managed, town, state, and federal regulations related to inspection and maintenance of stormwater control measures, and types of stormwater control measures. It will also provide guidance on what you should be looking for when inspecting your stormwater control measure and how to submit inspection forms to the town. So what is stormwater? Stormwater is considered precipitation or snowmelt that flows off land and impervious surfaces like driveways, sidewalks, and buildings. In a natural landscape, precipitation and snowmelt is absorbed into soil or flows into a water body. However, with increased development, more impervious surfaces are created that prevent infiltration from happening. When stormwater can't be infiltrated, it flows across hard surfaces as runoff, picking up and transporting pollutants along the way. Stormwater management is important because it reduces flooding, protects the environment, and improves water quality, which is especially important for a community like Franklin that gets its drinkable water from groundwater wells. When stormwater runoff isn't managed, it can cause several problems. For example, heavy precipitation can cause flooding of streams, lakes, rivers, and roadways. Infrastructure like pavement, bridges, culverts, utilities, and buildings are often affected by significant rain events, and erosion can also damage structures and degrade water quality as sediment, rocks, and other debris is transported with precipitation. Excess nutrients found in stormwater, like phosphorus, can also cause algal blooms, which can be toxic to humans, pets, and wildlife. How do we manage stormwater? Stormwater from an average rain event is usually managed through subsurface infrastructure that you may see around you every day. Catch basins collect the runoff and transport it through underground pipes that ultimately discharge to untreated water bodies like wetlands, lakes, ponds, and rivers. This untreated stormwater runoff can transport anything on the ground surface that it encounters, which often includes pollutants that harm water quality. Stormwater control measures, or SCMs for short, are designed to handle larger precipitation events, in most cases up to at least an inch of rainfall, and either slowly release that precipitation over time or infiltrate it into the subsurface. Most stormwater control measures provide some type of treatment to the runoff, removing pollutants like sediment and nutrients before they can enter water bodies. The town of Franklin owns and operates approximately 300 stormwater control measures. This includes inspecting and maintaining them to make sure that they're functioning properly to prevent flooding and improve water quality. This is a great start, but there are also about 130 privately owned stormwater control measures that can also help contribute to protecting water quality. Often, these systems are required to be built because there's an increase in impervious area during development, which generates more stormwater runoff. In recognition of protecting water quality, the town has created a bylaw that requires owners of these private systems to perform annual inspections and, if necessary, maintain their stormwater control measures. These systems are an investment not only for property owners, but also for the community and environment. You can learn more about that Franklin bylaw by accessing the code that's present on this slide or scanning the QR code. You can also contact Derek Adams, the Stormwater and Environmental Affairs Superintendent, at the contact information below. Franklin is also permitted under the EPA's Municipal Separate Storm Sewer System, or MS4 for short, permit. The MS4 permit manages stormwater discharges from the town's drainage system to make sure that stormwater runoff containing pollutants isn't entering the drainage system. This permit requires Franklin and over 200 other towns and cities in Massachusetts to maintain their drainage system and prevent pollutants from entering water bodies. Under the permit, Franklin is required to reduce about 2,200 pounds of phosphorus from entering the Charles River and connected water bodies by 2038. Every pound of phosphorus removed costs about $50,000 to $100,000, and this cost is currently funded through the town's operational budget. Franklin is doing what they can to reduce phosphorus and related phosphorus costs by investing in its stormwater control measures, sweeping streets to remove pollutants, and cleaning their catch basins, but they still need the help of private stormwater control measure owners to keep costs down.
Common types of SCMs include dry detention basins, infiltration basins, and rain gardens. Additional common types are wet ponds, gravel or constructed wetlands, and vegetated swales. Common SCM components include inlet and outlet control structures and pipes, pretreatment systems, overflow spillways, underdrains and cleanouts, side slopes and embankments, impoundment areas, vegetation, and safety features. Here is an example of an inlet and an outlet from a stormwater control measure. On the left, you can see an inlet. In this case, it's a plastic pipe that daylights into the control measure. It has some rock riprap protection as an apron at the outlet of the pipe. And on the right, you can see an outlet of the control measure, which is a large concrete structure. These typically have trash racks, and they have openings at various elevations to control different rain events. Control measures with inlet and outlet control structures typically include detention basins, infiltration basins, wet ponds, rain gardens, constructed wetlands and gravel wetlands, and vegetated swales. This photo shows the inlet on the left and the outlet of the control measure on the right. When inlets and outlets are filled with litter, debris, sediment, overgrown vegetation, or other items that prevent the flow of water, this can be problematic. When structures are not functioning, they can make the entire area more susceptible to flooding. Here's an example of a pretreatment system. In this case, water flows to a sediment forebay before it enters the main control measure. Here's an example of a cross-section view of an infiltration basin. On the bottom left, you can see the forebay highlighted. The way this system works is that water would flow where inflow is depicted on the diagram into some type of energy dissipation device, a plunge pool or an apron that slows the water down before it enters into the forebay. The sediment forebay collects sediment, debris, trash, etc. before water would then flow into the remainder of the infiltration basin that would allow for infiltration. By having a forebay, you're adding a place where this debris and sediment is concentrated. And if through routine maintenance, the maintenance burden is reduced as opposed to allowing the sediment and debris and trash to spread throughout the entire infiltration basin. Deep sump catch basins and water quality units are two types of pretreatment systems that are below ground, and they require a higher level of training to investigate. It is often best to hire a third party to evaluate these structures. If you have questions on how to maintain these systems and safely access them, please reach out to the DPW. Most control measures have pretreatment mechanisms. This would include detention basins, infiltration basins, wet ponds, rain gardens, gravel, constructed wetlands, vegetated swales, and others. The common problem that occurs with these is a lack of maintenance such that debris and sediment has built up in the pretreatment system. When this happens, it often renders the pretreatment system ineffective, and nutrients and sediment are discharged directly downstream. Overflow spillways are common in control measures. These are used to provide a secondary outlet path for water in the event of an extreme rain event or clogging or failure of the primary outlet of the control measure. Overflow spillways, also known as emergency spillways, are commonly found with detention basins, infiltration basins, wet ponds, bioretention systems, rain gardens, gravel constructed wetlands, and vegetated swales. The figure here depicts an emergency spillway located in the red oval. Erosion is a common problem that occurs with overflow spillways. If not properly maintained or protected with riprap armament or other hard armament, erosion can occur which could widen the spillway size and deteriorate the embankment. When this occurs, the water quality volume desired is no longer captured in the system, and the entire SCM could no longer be treating the desired amount of water that it's intended to. Additional problems can occur when there's excessive vegetative growth. When this happens and the overflow spillway is needed in a large storm event, vegetation can block the outlet path of the spillway. Next, we'll discuss underdrains and cleanouts. SCMs with underdrains and cleanouts include detention basins, infiltration basins, wet ponds, biofiltration, bioretention, rain gardens, gravel constructed wetlands, and porous pavement. Underdrains and cleanouts are used to distribute water that is seeping subsurface.
Side slopes and embankments help stabilize the soil and prevent erosion, especially during heavy rainfall. This ensures that the stormwater control measures remain effective and the surrounding areas are protected. They guide and manage the flow of stormwater, directing it towards designated areas for infiltration, detention, or treatment. This helps in controlling the speed and volume of runoff. They also provide structural support to stormwater control features like basins and ponds, ensuring they maintain their shape and function over time. Some common stormwater control measures with side slopes and embankments include detention basins, infiltration basins, wet ponds, biofiltration or bioretention basins, gravel or constructed wetlands, and vegetated swales. Some common problems that affect side slopes and embankments occur when concentrated flow of runoff leads to excessive erosion of the side slopes. This can potentially cause embankment failure from lack of vegetation growth. Failure of side slopes and embankments can lead to loss of storage capacity during large events. Vegetative growth or woody growth is also an important thing to look out for when you're trying to maintain your side slopes and embankments.
Impoundment areas help regulate water flow and reduce the risk of flooding downstream by temporarily storing excess stormwater during heavy rain or snowmelt. These impoundment areas are used to collect the water and hold it so that it can be treated through the processes that are present in the various types of control measures. They allow sediments and pollutants to settle out of the water before they're released, which also improves water quality. And by controlling the release of stored water, impoundment areas help maintain a steady flow in downstream water bodies, preventing erosion and protecting aquatic habitats. Detention basins, infiltration basins, wet ponds, bioretention, biofiltration systems, rain gardens, gravel constructed wetlands, and water quality swales all include some form of impoundment. Sediments can build up in the impoundment area, which can reduce its capacity to store stormwater and cause blockages. Excessive growth of vegetation is another common problem, including invasive species. The vegetation can obstruct water flow and reduce the efficiency of the stormwater system. Additionally, erosion, animal burrows, and other factors can cause damage and compromise the integrity of the impoundment. The first photo here shows bare spots in the impoundment, where vegetation is not growing. Secondly, we have an example of erosion on the side slopes. And lastly, you can see overgrowth, which inhibits access and can cause other issues with the impoundment. Nearly all SCMs have some sort of vegetation, including detention basins, infiltration basins, wet ponds, bioretention, biofiltration systems, rain gardens, gravel, constructed wetlands, and water quality swales. These common problems include bare spots, seepage, overgrowth, erosion of side slopes, access issues, and trash and debris accumulation. Fencing and gentle side slopes are two important safety features that are common in many control measures. Safety fence is important for preventing accidental falls into control measures and are particularly important in areas with steep slopes or where children or pets might be present. Gentle slopes, such as a 3 horizontal to 1 vertical slope, help stabilize the soil and reduces the risk of erosion. It also is an important safety feature because it makes it safer for maintenance crews to access the work area and service the control measure. Landscaping and vegetation management is very important for the long-term success of these control measures. The goal is to minimize the establishment or the takeover of non-intentional woody vegetation in the control measures. At least twice per year, we should mow and take care of the landscaping in these control measures and remove the clippings and material. Any debris and litter should be removed on a regular basis to limit anything that might migrate downstream away from the control measure. Additionally, sediment removal must occur often. It should occur quarterly for the first year and then as needed based on the typical buildup seen in the system. At least twice a year and after very large rain events, the structural integrity of the control measure should be observed. Here we want to look for signs of erosion and channelization and degradation of the slopes and the flow paths designed to convey water into the control measure. The goal of these systems is to have control measures where the impoundment can be drained within 72 hours of the storm event.
The town's stormwater utility fee began on July 1st, 2023. The fee, and the related number of billing units, is based on the amount of impervious area present on a parcel. Property owners can apply for a credit through the link listed in this slide if they demonstrate that they have maintained stormwater controls that either reduce stormwater quantity or improve stormwater quality. QR the code for the credit application. The inspection forms that were mentioned throughout this presentation can be found by scanning the QR code below. Natalie Regan-Lampert, the town's GIS specialist, will provide more information about how to access and use these forms in the next slides. If you'd like to learn more about the Town of Franklin's Stormwater Management Program, or if you have any questions, you can scan the QR code or use the link on this slide. Thanks for your time.
So if you are looking to fill out a Stormwater Control Measures certification in Viewpoint for the Town of Franklin, one of the quickest ways to get there is from our town website, franklinma.gov, and you would just go to the search bar, type in Viewpoint, hit search, and go to the very first result, which is Viewpoint Permitting. And once that loads up, you're in our licensing center. And you would look for the Department of Public Works section. Click on that. And that will bring you a list of all our available permits, licenses, certifications, including the Stormwater Control Measures certification that you are looking to fill out with me today. This first page that you come to was going to ask you to confirm your contact information. And that's the information that you would have signed up with: your first and last name, email address, and that's what the account's linked to, phone number, address, and that type of information. Once you confirm that that's all correct, you can proceed to the next step. And the next step is picking the location of your stormwater control measure that you are certifying today. And that's important. You may have more than one, and you may have more than one piece of land. You may own more than one parcel, have multiple addresses, that type of thing. So you just want to make sure that you use the right one for the one that you're doing today. I'm going to use the address for our DPW Engineering and Admin building. You would obviously use your own address. You just want to make sure that the right one pops up. This looks good to me. Okay, and we'll jump right into the specific applicant information for this certification. And that is not necessarily going to be the same as the individual that is applying through their Viewpoint account. Just show you what the options are for applicant type, and this is why it may not be the same. We give you the option of being the property owner, manager, or other. Not sure exactly who else would be applying, but we have the option. Just select other to show you. I guess we could be the landscaper. And enter a phone number. All of the required pieces of information have an asterisk next to the title of the box. If you do not fill those out, you cannot proceed to the next step, and that applies the whole way through the application. So you can see enter in the information. You could also, if you pick different ones, different options come up. All right. In our next section, we're going to go over inspection and maintenance information. And this would be the information that you collected or are collecting during your inspection of the actual stormwater control measure. So today, for example, we're going to pick a rain garden. And you're able to select your date right off a calendar. We say we inspected that earlier this week. You would enter the inspector's name or potentially like a position within the company that did the inspection. And just the location on the property where your stormwater control measure is located. Whether we're looking for whether it was clear or whether it was rainy. And you want to put the date of the most recent maintenance. So we'll say that that was earlier this week as well. And previously, we're going to say that we did some work on this one in the springtime. And that it is maintained by the DPW or whoever maintains it. And what type of maintenance did we do on our most recent maintenance? We did a little mowing and weeding, debris removal, and looks like we checked everything. Once you check off everything that you need to, you can move on to the next section. We also have some examples here of recommended maintenance procedures and frequency. All right, I'm just going to ask you specifically about the condition, what your findings were when you assessed the condition. Just want to go through and you want to answer honestly, obviously, what the assessment of the site was. I'm just going through and I'm selecting some options here. For example, obviously your answers will differ. All right, so the next few pages are just quick condition assessments, and it is specific to different facets of that inspection. And you can select all that apply. And if there's anything else that was inspected that's not on this list, please feel free to use the other box and briefly explain what else might have been inspected. We're going to say that it was in good condition, but we did see some excess vegetation, for example. Next up is our sediment depth, which you would measure in inches, and then you could report here, for example, 1 inch, and move right on to the next section. If you have a pretreatment system, you can specify what type of pretreatment system you do have. If you do not, you just enter NA or not applicable and move right on. The inlet condition, pretty straightforward. Just check all that apply as in the previous sections. And same with the outlet and the outlet control structure. You're just going through and you're reporting your findings. Loading control. And deposits. You have vegetation. And also you want to be sure to, if you do have vegetation in your control measure, you want to just check off whether it's healthy or unhealthy, in addition to selecting any of the other options that apply. Over here you can see questions pertaining to erosion. So we check anything that, any areas that you observed erosion or any types of erosion that might apply. Just say there was some displaced riprap, for example. And right here, if there's anything else that you would want the folks receiving this application for certification to consider or to be aware of, you can leave a note right here in the additional comments section. And looping back to what I mentioned at the very beginning, if you do have additional stormwater controls on this property, you just fill out a separate assessment for each one. You just submit a separate application. But as you can see, it's a very quick application for the certification. Just takes a few minutes. You just put the number that you have. Let's say you have 2, 3, or if you do just have the 1. And we'd also like you to include a photo, at least 2 photos of your stormwater control measure from 2 different perspectives. So whatever perspectives make sense in your specific situation. If you feel the need to include more than 2, you can do that right here by adding an attachment. But I'll show you real quick the process to upload a photo. And you would upload them there. If you want to add another, you just write a brief description, if you'd like, of what that additional attachment is. And then once those are all uploaded, you can move on to the next section. It's just confirming your submission. This gives you a chance to look over anything that might be missing or any questions you might have answered wrong. This gives you a chance to correct all that. Just give it a quick flip through, make sure it's all right. And as soon as you're happy with your form, you scroll down to the bottom, confirm and submit.